start. Well, in the last 2 days, we've been looking at uh, clustering, that is under unsupervised learning model, and the most exclusive one that we actually touched on is the exclusive clustering, which we said must force an element or a data point to be in exactly one cluster. Of course, uh, the interest of every data scientist is to ensure that we get exclusive clusters so as to report the best results. Then we say there are two models that can be built under exclusive clustering. One of them being K-means model. And K-means actually leverages on Euclidean distance between an element and the centroid, where the centroid is the centermost uh, data pair in a 2D Cartesian plane. We also looked at the steps of building a K-means model. One was the first step was to initialize centroids, and one was being done randomly. The second one was to calculate the Euclidean distance between each point and the randomly selected centroid. Then you assign clusters using in the indices like 0, 1 up to the nth or 8th cluster based on the minimum distance that is calculated between the two, between the data point and the Euclidean distance. Then from there we recalculated the centroids, and we iterated the process from level 2. We worked with an example, and we were able to stop at iteration 2 where we were able to find the next cluster. Then we concluded that uh, based on indexes that have been shown, when we were now to cluster, now it's just taking us back to the question. We were able to cluster some books as romance books and others as action-based books because of the indexes where they fell in. Then we also say that it is implemented using sklearn.cluster library in Python. We didn't stop there. We looked at another exclusive clustering model called density-based spatial clustering of applications with noise or DBSCAN, which can be used to identify outliers, and that's its most important feature. Another feature of it is that it can also cluster nested clusters. That is a cluster within a cluster. DBSCAN can actually cover and nest and do that because in as much as it is leveraging on the Euclidean distance, it is also actually leveraging a lot on a random point M, and also the core points near that random point in what we call an epsilon or a radius of a coinstance. The coinstance is basically a minimum sample that are going to come together to form a coinstance. So the epsilon is always a float from 0.01 all the way up to 0.99. So based on your radius or epsilon, you'll be able to find the minimum number of samples, and you'll be able to form a cluster using the minimum number of samples. Then yesterday we talked about hyperparameter tuning, and we said this is the process of systematically searching for the optimal configuration of hyperparameters that define the behavior of a machine learning model. And it involves selecting a set of hyperparameters, defining a search space, and then using various techniques such as grid search, random search, or more advanced methods like Bayesian optimization or genetic algorithms to explore different combinations of hyperparameters. Then the goal was to find the combination that results in the best performance of the model on a validation dataset. And this one could ultimately lead to improved accuracy, generalization, and robustness of the model. It is always essential for maximizing the output, to ensure that we get to improve the machine learning model. One of such a hyperparameter tuning technique is the grid search. Here, we said we use the mathematical approach of combination and permutation to actually ensure that we iterate throughout, let's say, a tuple or a list until they are exhausted, and we get the one that yields the best result. In Python, the research is basically a for loop that has been implemented. For loop with most enough for loop that have been implemented. We also looked at other types of classes. We said we are not going to talk about them. Overlapping clustering, which is actually not recommended. A type of clustering where a data point can find itself in two or more clusters, but that's not what we want. Then we also said hierarchical clustering, where after implementing the exclusive clustering, you can still go ahead and implement hierarchical clustering. We've not implemented it here, but I have brought in another model which we had looked before called the linear regression model, which can help us actually regress the clusters or try and predict which cluster an item will fall into. So we have also probabilistic, which works on based on probability. Then the last step was actually evaluating clustering models. Any machine learning model must be evaluated, just like we evaluated the supervised learning model. We can also evaluate the unsupervised learning models, specifically the clustering model. There are two ways: the inertia method and also the silhouette score. And in the inertia method, we just sum of square distances to the centroid. And we said for inertia method, we settled for the least inertia score because we used within class a sum of squares. So it means we may want to work as much as we can to reduce these distances to the bare minimum. And that one will signify that the clusters actually were formed from data points which were closely packed to each other. Then from the silhouette score, we were able to find to use the elbow method, where first of all, every item in the data space was treated as one cluster. Then we calculate the within cluster sum of squares. Then we note that value. We try and disintegrate it into using K-means method or DBSCAN method, and after that we calculate within cluster sum of squares and also note the value. We can try and disintegrate it further. If it could be disintegrated further, we could still do it, but the optimal point will actually be shown on the elbow method, where the elbow will bend. See that at 3, meaning we can still have 4 clusters, but it will not be as optimal as 3. Okay, then we also calculated the silhouette score, and in the silhouette score, we had 2 data points, B and A, and we said A is the distance between a data point and another data point in the same cluster, while B is the distance between a data point and another data point in a different cluster. Then you take just the difference divided by the maximum between the two, and that is the silhouette score. Silhouette score should be larger. A smaller silhouette score implies that our clustering was not done perfectly, and that means that the distance between the B actually was larger, and that's what we do not want. So now that we've gotten that information swiftly, we can now proceed to building our machine learning model. Like I said, we are importing from clustering, KMeans and DBSCAN. Are you there? Okay. And I've been talking and saying about this, that a good data scientist always has this open, even if you have AI which is going to help you generate the codes, but you must always have this link open. It's your go to proof of concept, or what do we call it? This English word. So you can even start here. It's the clustering method. From the clustering, you have K-means, and we also have, as you can see, there are agglomerative clustering, which if you get time, you can come here and implement. We also have DBSCAN. We also have another one called HDBSCAN, I think on a high density. So it is an optimizer of DBSCAN. We also, but we always fear it, I think, because of the fact that it is, when it's high density, it can work based on your local data set, but at the end of the day, it overfits in your production environment. So in our case, we're going to implement KMeans and DBSCAN. So I'm going to open the two. And it's clustered data by trying to separate samples in n groups of equal variances, minimizing criterion known as inertia, or within cluster sum of squares. And it requires the number of classes to be specified. It scales well with the large data sets. That is to say, as the data set increases, K-means actually also works best. So K-means, we may also want to look at its, if you click on it, you will be able to see its parameters. The number of clusters has been taken to be 8. That is default. But what did I say? We are going to use grid search to help us identify the optimal number of clusters. And the grid search will also be, we'll also draw using an elbow curve so that you can see where the curve actually. Yeah. Then others leave the default as they are, but I want to talk about maximum iterations. How many times are you going to do this? 300 times. That's a large number, of which most of the time hata hatufikangi huko. Then the guy who developed this named it Lloyd algorithm. So it's an algorithm that you just use to work on your data. But if you are a developer, you can start developing all these shenanigans we talked about up there. Yeah, companies just crop up like the SK Learn. What they do, by the way, how they earn money, you might want to know. This is an open source. How do they earn money? Oh, the big companies like Google just donate. Yeah, they just donate and in billions of dollars. So at the end of the day, Skyline is a very profitable company. So you see, it's just a community of developers who came together. So at the end of the day, they registered with the government of the United States. After that, now companies using their products, by the way, they don't coerce you, they don't force you to donate, but they send you like they send you reminders and everything. Like I use JavaScript PM package a lot. So they always send me reminders, Joseph, you can donate as low as $1. You guys joke with $1 from 100 million people. That's $100 million. And it's someone kuna tu mtu mwenye from his salary he will donate like $10 monthly. Because he knows these things helps him a lot in his job. Yeah, so if you have money and honestly one day if I have money I can also donate because it helps me. So they keep on building so many uh, uh, important things that helps people outside. So that's how SK Learn and all these other and open source programs actually get money, mostly from donations. This one we said of high density separated by areas of low density. Then when you look at the hyperparameters there, the epsilon, what did you say of the epsilon? That is the radius of a co-instance. Yeah, the minimum sample should be at least 5. So again, the DBSCAN is going to do what to help us, and they're also using the Euclidean metric to ensure that the distances are calculated perfectly. But we're going to use grid search CV to ensure that we get the best hyperparameters for our case. Now that we've known this, we can now go ahead and look at our dataset. So from skmean.cluster, we import KMeans and DBSCAN. Well, DBSCAN works best with scale data because especially if your data set has, and not just DBSCAN, most of the machine learning models, if your data set has categorical variables or non-numerical variables, it is highly advised that you import standard scalar from pre-processing and robust scalar for DBSCAN so that it is actually scaled robustly. Then metrics that we are going to use is the silhouette score. The inertia method, we always develop it on our own, and you're going to see how we're going to do that. We just calculate the within cluster K means within cluster sum of squares, then we draw our elbows, and that's the inertia method. There is nothing else. Then the LPLT is going to help us plot the curves. We might also want to import date time and time delta if you are going to work with time data sets, and logging, especially for production environment, to log information. It helps me a lot. I was wondering where this thing is used, and it really helps a lot. Especially if your up is down, you just go to the logs and you will be able to see what is has transpired. So there's a day I just put a full stop in a code, and I was wondering what's the problem. I've reviewed it, Mekata. Now, going to the logs, unexpected full stop at the end of the code. I was like, Jesus. So you just go and delete the code and restart the application and it works. So that's how important logs are. So we set it up for production grade error tracking. It's used just for tracking error. And the basic configuration is that we just need the information, and it should give us with time, the level name, and the message. And let's look at the log, one of the log. Yes. So see the date and time, the level name with information, and the message itself. The message, you are the one who is going to define. Yes. Suppress warnings for cleaner output. We don't want to explain that. And we also want to import our data 209 and data 2010. Then data 209, we verify that it is there. Then after that, we can now combine them. But there is this thing called RFM. RFM in clustering is used to segment customers based on their transaction history, recency, frequency, and monetary. How recent, how frequent, and how much. So RFM analysis helps identify distinct customer groups by considering how recently they made the purchase, recency, how often they buy, frequency, and how much they spend, monetary. These RFM values can then be used as features in KMeans clustering model to group customers with similar purchasing behaviors into clusters. So customers who purchase frequently, or who recently made a purchase, or who use a lot of money, all these things are actually going to help us do RFM analysis. But before doing RFM analysis, we must combine data sets from what we did yesterday. We form a data frame, and after forming a data frame, we use concat to append the first frame onto the last frame onto the first, which means be very keen. Don't write the data 2010 here. Don't write data 2010 as the first one, because 209 will be padded below 2010. So when you do that and realize that it's a large data set of 1 million rows and 8 columns, then we now start synthetic extension for better recency variation. Extending data set with synthetic dates for recency variation. We always use the random seed of for that is the reproducibility of the number of times a random sample should be selected. Then we extended data. We just okay. When you want to manipulate data sets at high degree level, like the one we are going to do, it is highly recommended that you do what, or advisable that you use the copy of the data, so that the original one remains. So extended data, we get data.copy. Then date range, the period of date range, we start from 2010. It should be 209, not 2010. Should start from 209. Yeah, we are just trying to implement. I mean, it's not like it was given, but we're just trying to be data analytics in mindset so that we get the best result. So I think randomly, we're just choosing a random date. They're just going to be assigned. You see, when we said that the start date, said here that the start date is 2010, November 1st, and then that is to 2012 December 1st. So basically, it means within 30 days. So all the data will be assigned. You see, hakuna data hapa. So all the data will be assigned the date between these specification. So you will find some dates repeating themselves. So extended data, then we create a new called invoice date. Of course, we didn't have it here. Yeah, invoice. We create a new uh, column called invoice date. And yes, oh, you just expand it. Oh, it is the invoice date. Okay, so it is up to 12th 9th 2011. That is to say, I don't know how they write it. I don't know if it is the American format, because this one would now mean December 9th 2011. But let me guess, is the American format. That's not happening. Oh, it has selected. December 9th, yeah. Thank you. So they're using the American format, December 9th, 2011. So the last date is actually December 9th, 2011. Then the first date, but I don't think if there was a need of Nini, because the invoice date exists here. No, this is where I can lie. The invoice date is already existing, so there is no need of creating a new one. Unless, yeah, this is the invoice date. And it starts from December 1st, 2009. So there was no need of creating a new invoice date. The only thing we can use this information to do is to calculate the purchases that were made on a specific date, calculate all of them and group them together. So we are going to group purchases by dates. I think that's the analysis that we should make here. So this one is because this one will actually make us land into a beach. And I saw it. Maybe that's the reason why Qatar squared. Mm. The silhouette score 35. So let it maybe. So we're being told that date time delta does not match format. Okay, so that one, let's say I do it for us very fast. It is converting the invoice date to time delta in Python so that you can use it, except that the format that is being used is what? Why is it not pasting? Maybe. Let me copy that. It's just a matter of getting a new code. Okay. So now that this one is actually not needed, we can delete it. We've now changed the invoice date to a date time, so we can use it to do the date time things that we may want to. Then we filter out negative quantities and missing customer IDs. For we drop those customers ID that are null, because how are we going to segment those who doesn't exist? Then we also use the quantities which are greater than 0, meaning we exclude the data quantity. You see how it has been done. That data is actually data, then we single out data quantity greater than 0. So this part here, quantity, sorry, is a column, yes. Yeah. Mm. Then next, we aggregate to customer level recency, frequency, and monetary features. So we are actually using customer frequency, monetary, and recency. So recency is actually the invoice date, most recent. Then frequency, the count of invoices. How many times does this customer, how many times did we invoice them? And total spend is actually the monetary. So this is what is called RFM analysis in clustering or customer segmentation. So you've been, I know you've been coming across this word customer segmentation in Python. You've been wondering. So this is it. And look at how it is done. We assign all these things into a variable called RFM. Then we are grouping customer ID by the aggregations of the following. So we group customer ID, meaning a specific customer. We group them by the invoice date, and the invoice date will be a function that that a lambda x. And what did you say about lambda? Lambda is a function. Define function. So the name of the function is always hidden, but it has something called an argument x. This argument x, maybe it's a date. So the reference date minus the maximum, then we change that into days. The function ends here. The function ends here. Then after getting the maximum date with the reference date, we convert it to days. So we just want to see the most recent customers, that is. Then we also use the invoice. By the way, these ones are all columns, and they're the ones that we're using to segment. df.info or df.column should show you. So if I click here, df.columns, the data. I'm used to df. So we are using total spent, we are using invoice date and invoice itself. And the invoice just help us to count how much or how many invoices were sent to this specific customer. The sum, how much, the sum of all, the total sum from the invoices that were sent, then the invoice date, how recent were these invoices sent. Then we reset index. To reset index in Python, if you write, what does it do? It basically reorganizes the sequence, nothing more. So it just reorganizes the sequence. Then rfm.columns are now called the following: customer ID, recency, frequency, and monetary. So these are now been named into rfm.columns. Yes, to a specific customer. Remember, we are grouping by customer ID. Yeah, so we are grouping by customer ID. So take note of the reference date up there. It had been defined before. So the reference date was defined as the invoice date, the maximum, like the maximum is the most recent day. No, no. So if you go through if you go through all that column, the maximum date is the most recent day or the most recent date. Yes. So plus PD dot time delta, this is equals to 1. So you just add one day. So it means that if the day keeps on changing, the reference date also keeps changing, which means it is the current day now. So the reference date is the current day, which is the date today. So when you come back to look at the invoice date, what did we say? Is now the current day, the date today, so, minus the most recent. So my x dot max, you see, and that's what the argument x means. So at the end of the day, what are you going to have? At the end of the day, we are going to work with the most recent number of days as the invoice date. Hata kama ni moja, then that's the recency that we're talking about. So I guess the problem was coming up. I didn't explain this line of code. Now we check for sufficient data. If the length of RFM is less than 10, then we want small number of unique customers. Clustering may be limited, but you see, they are not been, we have not been one, meaning RFM is less than 10. So we are good. Clustering cannot be limited because, and then they also show the length of RFM. But we can also look at the length of RFM by using else. So in that case, we use logger.info, not logger.warning, because just getting the information now. So we can proceed with clustering or with RFM analysis. Then we put in a comma. Sorry. Length of RFM. One thing maybe doesn't work with else statement, but the message has been, we can proceed, and they are 5881. But wait, why this error? I don't know why the error. Not all arguments converted using string formatting. Maybe it's coming from using else with loggers. Let's see print. Yep. So we log transform for skewed data. Upper. We are doing. Do you remember transformation in feature engineering? So let me. I love using evidence. This is an evidence-based class. Feature engineering is the process of creating new features or changing or transforming the features of existing ones to improve the performance of a machine learning model. We have different types: feature creation, feature transformation, feature extraction, feature selection, and feature scaling. Then my main point of interest is feature transformation. So you will not say that you are not taught this. Here it is. Feature transformation involves changing or transforming the features into a more suitable representation then of a machine learning model. Under this process, we have 4 types. Normalization. Think of normalization in principal component analysis. Okay, itutafanya hapo mbele. Actually, it's just a stone throw away. If not next week, but one. Then feature scaling, then feature encoding. The last one, which is the one the reason why I came here, is transformation. Using mathematical expressions such as logarithmic, using mathematical expressions such as logarithmic to change the distribution or scale of data. And that is it. So when we come back to feature, what we are doing here, we are using mathematical logarithmic expression to transform features. But you might want to ask yourself, what is it doing? So to answer that, we go back to NumPy documentation. evidence-based class. Sorry. Then you just search np.log. MATLAB for mathematics users using NumPy. Should be for mathematics users also. NumPy tutorials. Deep learning. I think we are going to use it more on deep learning, linear algebra. Allow me to just to explicitly search for this. np.float, masquerades, np. something, sentiment analysis on notable speech of the last decade, deep reinforcement learning with POM from pixels, deep learning on MNIST data set, analyzing the impact of lockdown on air quality in Delhi, India. You see projects, the way projects are here with nice ones. Kwanza nimerudishwa kwa kusoma. Hey, no. Mathematics transformation. Yeah, so these are the mathematics transformation parameters that exist or methods that exist in NumPy, like exponential, the sigmoid. Why can't I find the tan h? Yes, then p dot. So I'm more specifically interested in np dot logarithmic function, logarithmic, which is I'm not finding it here. Or we can also just say np dot log 1p, just like that. That calculates the natural logarithmic of 1 plus the input array element y. Specifically, it computes the logarithmic of 1 plus x, where x is the input value of the array. So, okay, you search EV explicitly, it will lead you to that page. So, here we go. Nice. So, x in this case is an array, or array like, for example, a data frame. That's why we did it using a data frame. And our data frame, I guess the data frame is the RFM something. Yeah, RFM for monetary. Also, the log for frequency and RFM for frequency. Why are you doing this? We're just transforming this to ensure that the skewness, data can be skewed to the right or to the left. So we just want to do away with skewness. Of course, that you cannot. You only skew numerical data, but yeah. So that's exactly what it does. It does. So you can come here and read that it returns a natural logarithm of one plus the input array element twice, one plus x. Then you might also want to ask yourself, why not NP log, just like this, which return natural algorithm element wise. This one, oh, this one adjusts for this natural logarithmic log 1p adjusts for skewness, while this one do not adjust for skewness. It just change into natural logarithmic. Then the log to base 10. This is what I wanted. So you see all these for mathematics terms. We are coming to find them. We are coming to find them in deep learning. So we'll visit NumPy a lot, a lot, a lot, even for statistics, but mostly for we are coming to find them mostly in deep learning, especially when we are working with artificial neural networks and everything. So with that said, we've seen where we've noted all this. Now, how should I know when to change the data? You should know when to change the data, especially after what we are not doing in this reading. We are not sketching the data sets, the distribution, the skewness, and everything. So if you were to do it, you could have seen. Let me tell AI because of time to give you a code to perform EDA, exploratory data analysis. So the histogram here is just going to visualize the distribution of quantity, price, and total spend. And that's what we are actually interested in. We just want to see the distribution, how they're distributed. Is it skewed to the right, skewed to the left, or what what is the skewness? So, and in any machine learning task, ensure you draw you've seen why. This one is, you can only know this if you have the EDS up here showing the distribution. So we are not always drawing those graphs in Python for no reason. They have their purpose. And I've seen a senior data scientist cleaning the data set well, importing it in Power BI, drawing a very nice looking dashboard just to build a machine learning model. I was like, guy, you're not reporting this to the stakeholder. He told me, I'm used to building this in Power BI to ensure that I get to understand my data in depthly before I develop my model. So you see, this one, this information, we could have only known after seeing the mission. Wacha imalize. You're not interested in the information it's generating. Now, features for clustering. We want to cluster for recency, log frequency, and log monetary. We just transformed. It's just monetary, just that it has been transformed using logarithmic function. Then the X that we're now going to use are the RFM features. Then we handle missing value for RFM features. If X is null, then what do we do? If there is any X that is null, that's what we are trying to say. If there is any, and why are we using method chaining in Python? Remember, X has how many items? X is an array of arrays. X itself is an array of arrays. So the innermost recency is still an array in its own because it has values that are series like. So the first any accounts for the arrays in features. The second any account for the array in the array in features. Now method chaining in Python. Then we want missing values detected, filling with median. Then you fill it with median. That is if it is a null. But you see, kuna warning him tumepewa hapo, so it means that there were no null values. But it's very, very essential to fill in the null values. Now, once you've done this, is when we can go on and implement K-means clustering. So, you can notice that the part where we waste time, not just wasting time, but where we take most of our time, is when we are pre-processing data and performing EDA. Let me tell you, building a machine learning model is a 2 minute thing. But you should never build it with a dirty or as an unsuitable data set. That's why it is very, very advisable. You spend much of your time to clean it accordingly. So let's see if that one has been well picked. So the information we needed is here. Huku tulishafanya. So numerical, this one here. This one. Did not pick others. So that is always done immediately after doing the data set. Hmm? Oh, we're going to see the quantity, the mean, the price, the mean price, and the mean total spent. So EDA is very important, by the way, very, very important. Not just to machine learning, but also to any data professional. Ah, there's a problem. Yeah, this one ought to have been here. Ta-da. Let me just interrupt and finish. Total spend not in index. Why? Eh, what's happening? Yes. I'm wondering what is not happening. ID country, invoice stock, price, quantity. Oh, total spent, invoice stock code, description, quantity, invoice date, price. Total spend is the was a custom column. So we got to have included that by just saying data 209, Start 9. Just to be sure. Quantity. No, I hate running into errors. Then price. This was a column that was custom built during processing to help us. Okay. Error. None of the index are in columns. Oh, I've seen what I did. See here, I was trying to select what actually instead of just calculating it directly. Pen is now there. Yeah, so we can now continue. I total spend. Oh, yetu ni spent, yake ni spent. Where this little just So actually, this is the one I'm interested in. So the histogram. Okay, and this generating, we shall come back now. We now build them. We actually use the standardize the features using standard scalar, because you know what follows is the fit transform with x as the variable there. And what was x? X was now the RFM features that we are performing RFM analysis. Then after that, we now use elbow method to find the best value of k. First of all, inertia is an empty list. Silhouette score is an empty list. Remember the formula for calculating inertia and silhouette score. It applies here. So k range, like the range of k should range from 2 to the minimum between 8 and the length of x. But what is x? X, if you look at x here, is the RM features. The RM features consist of, there I think there are three: recency, log, frequency, and monetary. So that is x. That's how we define x. RFM, those features there. The RFM, we also defined it up here as the group. Sorry, the grouping. So the minimum between 8 and that, of course, they'll set for 3. We are doing this just to limit the k to the number of samples. Now we now use a for loop to iterate, calculate the inertia method and also the silhouette score, then append them into the list of, after which we are going to draw the values for inertia against the number of clusters. So just a for loop. For k in the range of k, here, k means is equals to k means the number of clusters is equals to k, number of clusters k, when k has been chosen as 2, the number of clusters is 2. The random set for reproducibility is always 10. Then the number of initializations are 10. If you do not know this, just leave it as a default like we saw there. Then we fit k means with the x scaled that we scaled up here. Then the inertia that has been calculated from each and every uh, value should be appended into the inertia list. When you are invited for coding exercises, these are some of the things they test, by the way, a lot. They will test your knowledge of working with lists, like what do you do with the list. It's called data structures and algorithms. Are you able to append values into the list? Are you able to pop values from the list? Are you able to remove value explicitly from the list? Yeah. So look at this. K means dot inertia is dot inertia underscore. This one is the standard way through which sklearn gives you a method to calculate inertia. So the formula remains up there. We saw in the theory. But now, when inertia has been calculated, it is calculated for each and every range of k. K, we said, ranges from 2 and the minimum of 8 and length of x. So when you calculate k, inertia, it is appended into the inertia's list. That's what's happening here. But if k is greater than 1 and the length of unique labels is also greater than 1, then the unique k-mean labels, k-mean labels, I think the best place to find all this, let's come to Democracy here. Attributes, cluster center. We have in here sum of square distances of samples to the closest cluster center weighted by the sample weights provided. So that is the inertia that we were talking about. Then labels is the dimensional array of shape, the number of samples, that is labels of each point. So each point actually has a number of samples. So when you come back here, for every unique label, we do what if k is greater than 1, and there also exists every unique label, we can calculate the silhouette score. Score is equal to silhouette score on X scaled K-means dot label. The silhouette score, in short, think think of label as the specific cluster. Then we say that the silhouette score was calculating B and A. So when you supply the labels and the X scale, it is going to calculate each and every value of X to the next one in each and every label. Yes, yes. So if you find the silhouette score, if you find the score, append it into the silhouette score value. Otherwise, yes. So let's see if it has given us the result. Yeah, it has given us the result, numerical histograms.png. Search it here, MNOP. Here it is. So the quantities are actually ranging between 0 and nini. So it's a very, very ambiguous one anyway. Then it's a very, very ambiguous one. And that's why, after noting this, as you can see, it is ranging from negative 4,000 to 4,000. Then the histograms are only at 0. That's when the prices are so much. But meaning the prices are also, if you can see, there are bars at negative 40,000. Yes, to change this scenario now. Yes. So when you do this, you are able to see that this is not the best data to use to build your model. So what you do some transformations. That's why you have the nodes, feature engineering and all the machine learning. So you know what to do as a machine learning engineer. So you just realize machine learning is not about building the models. It is about understanding the problem and building a model that can answer that problem explicitly. You can also do the same thing for box plot and also do the same thing for log transform histogram. So let's see how they look like. Then the correlation matrix. Jamani, technology is sweet. Uh, Once we've gotten that, we can now plot the elbow curve. The elbow curve, dot figure, then the subplots are there. Then we have plot K range against inertias, then mark with 0. When you say mark is equal to X, you know what it does. It marks with X. So the plot is actually X should be here and Y should be here. So K range unaweka kwa X. Then Y should be inertia. So as I can see, the nini has been taken as 8. Uh, the K range. Then the inertias are the values of the inertia which were calculated and appended into our list. After that, you now build title, elbow method for K means the number of clusters on X level and Y level inertia. Then we are able to see. For me, I'll settle with 5 as the optimum number of K. But someone can still settle with 3. But it depends. As you can see, 3 yields a higher inertia. But what did we say about inertia values? The lowest inertia value. Yeah, so in this case, the elbow starts being optimal at 3. Now, someone you can choose 3. But for me, I'll choose 5 because Number one, it produces the lowest inertia, and the elbow looks somehow uh, optimally fit at 5. Then you can also plot the silhouette score. When you plot the silhouette score against the K range starting from 1, and the silhouette score again the scores from 1 going forward. When you look at the K-means evaluation of PNG, it is here. The number of clusters against the silhouette score. The silhouette score, we said we should settle for the higher silhouette score. So the highest is 0.37. The number of clusters are 3. So these guys are settling at 3. Also, you can look at silhouette score at 5. Why? The reason why I chose 5 is 35, 34 point something. So in this reading, silhouette score actually tends to agree with me when I chose 30 with K-mean. When I chose 5 clusters for K-means and also decide to choose 5 clusters for silhouette score, it can still be better. But I said someone can still choose 37. Silhouette score will support that person fully because, as you can see, silhouette score should be the highest score. So let's see the choice. So the optimal K is the minimum between 3 and the length of x minus 1. So default to 3 if it cannot actually work. Then that's why you use the optimal K and the random set of 42. Then you just now implement the K means to predict. Okay, for them they have chosen 3. Personally, I could have chosen 5. The reason why they have chosen 3 is because of the silhouette cost value. Yes, of course, length of x minus 1 should be 2. So yeah, they're going for 2. Me, I'll definitely go for 3. Let's print and see what the minimum K is. So the optimal K is 3. Then we proceed and also evaluate K means. So when we evaluate the K means, as you could have seen from the select score, it was 37, so 36.94 according to the value of K silhouette score. This is so low. So this is a model that you cannot say you want to deploy. But it depends. The reason why it might be low is because the data set do not support, the transformations may have changed a lot. The data set also may not support our working. So in this case, if you are to build another model, you are going to see there will be another model called association rule, which can work best with this model. So customer segmentation cannot be implemented on this model because of the fact that the silhouette score is too low. This is not even just fair, low. Now for the DBSCAN, very fast because of time now. We implement DBSCAN and we use robust scalar. Then we transform the X robust is equal to robust scalar dot fit transform X. We are avoiding the standard scalar because the standard scalar is mostly used to transform to standard normal variables. But if you look at the formula of DBSCAN, it does not work just with the normal variables, but it also tends to work with the core instances, the epsilon. So you see, so it should be scaled robustly. To scale robustly basically means to go beyond just standard scaling. Then we are looking for the best epsilon and minimum number of samples. Epsilon values ranges from 0.3, 1.1, and 0.1. So we want to choose from the range of this one. And the best epsilon is 0.5. That is from DBSCAN in Skyline, you saw that this is always the default. The best silhouette is equal to -1. Then the best labels is equal to none. Then this is misleading, but let's see why it has been used. For epsilon in epsilon values, DBSCAN, you fit in the DBSCAN model using the epsilon. Remember, the for loop is going to iterate through each and every epsilon. So when epsilon is equal to epsilon, because you said for epsilon in epsilon values, so DBSCAN epsilon is equal to epsilon, meaning for the first epsilon value of 0.3 scan, epsilon will be 0.3. The minimum of number of samples have been fixed at 3. Then labels is equals to dbscan.fit predict x robust. If there are if the length of unique labels is greater than 1, meaning there exists unique labels which are greater than 1, then we can calculate silhouette score. Yeah, of course, you can only calculate silhouette score if there are more than two observations, two labels or two clusters. That's why we are saying if there exists unique labels of after fitting the DBSCAN, then we can get silhouette score. Remember how silhouette score is calculated: B minus A over maximum between B and A, where B is the distance between this label elements in this label and the next label. So if the labels are greater than 1 is when you can calculate silhouette score. And after calculating silhouette score, we use an inner for loop. And if the score is greater than the best silhouette, meaning then the best silhouette score is that score now. So I told you this one was misleading, and we knew why we put it as that -1. Always choose the least one so that you keep on updating. And the best epsilon now becomes the best epsilon that has been gotten from this range. And now the best labels is equals to labels. The final DBSCAN is now fitted using the best epsilon, and when you evaluate it, the score is 62. The same data set, different figures. DBSCAN has actually tried to work best. So it means if we could be able to do more and more grid searching and this one can go to 80, then we can deploy DBSCAN other than KMeans. Then we now save the results. We now save the results to customer segments.csv. Yeah, the DBSCAN clusters that has been done. KMeans clusters, DBSCAN cluster. So which means that this customer, let's see where he was classified. Cluster of 0. Remember, we have RFM, recency, frequency. So if 0 is recent, this customer, most of them are recent customers here. Yeah. After that, but remember, this is at 62%. Hiyo 38 ni mingi sana. After that, we now print the cluster summaries. It means clusters, the recency, cluster 0, we have 96, 1, we have for 80, and 2, we have 70. Log frequency 3, 2, and 5. This is for log, not for the normal one. Yes, for DBSCAN also the same thing. And also DBSCAN, as you can see, we also have -1, which we said is always for outliers. We can again visualize the clusters. That should be this one first. K-means cluster.png. It goes to K-mean cluster.png. That's it. So the clusters have been classified or recency and the number of days, and also log carry. I think they could have labels is equal to something. Why did they put it scatter? XY norm data age columns. See map now. Not giving me what I want, but I'm going to research more on it. What I mean from this KMeans class, I should be able to see purple, yellow, and the other color. What do they represent? And then integration with linear regression. We can now proceed to fit in. Remember, at 30, 32 and 62, to try and see which one will fall into cluster 2 linear regression R squared is 0.24. Cluster 0 linear squared is 0.20. That is for k-means only. I think they are using k-means. It will be for k-means, not for. Then cluster 1 linear regression is 0.9. These values are too low and we cannot use them to base our argument. But let us go through the code, what the code does. We just want to ensure that we can use linear regression to now try and predict the clusters. And we are importing linear regression from sklearn and saying for cluster in the k-means cluster that are not repeating themselves, meaning they're unique, then cluster data equals to RFM k-means cluster, which must be a cluster. So if length of the cluster data is greater than 1, then X cluster, meaning if there are more than one clusters, then the X cluster should be the cluster data that has only recency and log frequency, while Y cluster should be cluster data that has log monetary. So in short, we want to predict log monetary using recency and frequency. How much is this customer going to use based on how recent he does, and also how frequent does he purchase with us? Then the model is linear regression. Then we fit X cluster and Y cluster. Then we find the score only to end up with 24. So that is not something that can. Yeah, and that marks the end of a simple customer segmentation task in Python. YouTube has the best resources for this. Unfortunately, you're going to find welcome to my YouTube channel. It's unfortunate, but they also try their level best to explain points. Yes, that that's a very important question. That's where we are coming in here. Look at this. After we are done, we were able to see the clusters. Actually, the data set gives us the clusters. We were able to see the clusters here. 0 was the cluster of recency, RSM. 1 was the cluster of frequency, and and 2 was the cluster of monetary. So if a customer falls into 0, it means that they came in recently. They are most customers. If they fall into 1, it means that they frequently purchase with us. Then if they fall in at 2, then it means that these customers mostly use a lot, spend a lot of money. So please, from that you can just explain that those guys who spend a lot of money, there should be something through which we can see, so we can go back and see how they work. Like, we are always about money, nothing else. So we want to see what is this that is making these customers spend a lot of money, so that we implement whatever is making them spend a lot of money to the other customers. But mostly naona hapa ni recency tu. Okay. But you see, the model is 32%. So, any other question? Okay, but I just want to tell you that the a secret which should lie with you. The most important thing is to understand the theoretical approach to each and every model, then how to implement them in Python only. Because if you stick to uh, explaining data for one particular model, itakuramba vibaya sana when you're being given a different model from a totally different field. Yeah. So if you know, but if you know the theoretical approach and explanation, then you can adapt. You can just change the code. Most of the time, what we do is just copy paste the codes and and edit it accordingly. That's why you see editing with AI generated codes might not be difficult for me because it's something I'm used to. Yeah. Any other question?